Hey guys, these are the notes for the week of May 4th, 2020. Make sure you put your name and Algebra 2 at the top. All right, and what we're doing this week is we are going to talk about different strategies to multiply radical expressions. And if you're labeling sections and things, this is 6.4. Okay. All right, so we have some examples that'll start easy, get a little bit harder. And please remember that you can pause, catch up. I'm going to start skipping some steps in these because you guys should be getting a little bit better at simplifying these. So I'm going to point out some shortcuts and I'm going to start utilizing those shortcuts. So if you don't know what I'm doing, go back and break it down the way you have and make sure you're getting the same answers that I am. Okay? So the big key to these when you do these problems is to first multiply and then simplify. Okay, remember that when we did addition and subtraction, if you had something like 4 radical 12 plus 6 radical 8, I asked you guys to draw a line down in between them, do them completely separately, so you simplified first, and then you added your answers together. This is going to be backwards because you can multiply these terms together. You don't have to separate them that way. So this is going to be a different process, and I think easier, actually, than adding and subtracting. Okay, so here's example number 1. It is rad 80 times rad 10. So the first thing you're going to do is multiply. We're going to multiply anything under the radical and leave it underneath the radical. If you had values out front, you would multiply those numbers together and they would go out front. And you're going to see that in my next example. And then once you get here, you're going to simplify just like you have been. So I'm going to actually break this 800 not back into 80 and 10, but I'm going to think smarter, not harder, and I'm going to go to 108. The reason I'm going to do that, and here's what I kind of want you to think about, is if you can break into perfect squares. So if you can break into perfect squares, then you should be able to just break these radicals right down. So the root of 100, because it's rad 10 and rad 10, you get a pair of 10s, and therefore it's a perfect square, and it's just plain 10, right? No radical over it, just plain 10. So I'm going to start doing that. I haven't in any of the previous lectures. Radical 8 is 2 radical 4, and 4 is just plain 2. And so I have 10 times 2. This is my only radical left. So this is 20 radical 2. Okay, so multiply, then simplify, break into simpler radicals. If you can break into perfect squares, break it into as many perfect squares as you can and go from there. All right, so I'm going to go to my next example. Example number 2 looks like 3 rad 35 times 2 rad 7. All right, so we're going to multiply first. If you have coefficients, multiply them together. 3 times 2 is 6. And then I'm going to go 35 times 7, which is 245. So anything outside the radical gets multiplied together and put outside the radical. Anything under the radical gets multiplied and put underneath the radical. Now you're going to simplify just like you have been. So 245 will break down into rad 5 and rad 49. The root of 49 is 7. So I'm going to have the 3 from here, the 7 from here, and the radical left over. Multiply these together, 21 rad 5. Okay? Let's see. Oh my gosh. I did that so wrong. Did anybody catch the boo-boo that I just made? Holy cow. Okay, it was kind of a big one. If you went, what did you just do? I used this green 3 from up here instead of the 6 from right here. So I'm going to go back a couple of steps. I am very sorry. I hate it when I make these kind of boo-boos in a video. Back, back, back. Oops, didn't need that one. Okay, so we're there. Now, ignore everything in the top. We have this 6 that comes down times 7 that comes down, radical 5. So 42 radical 5. So sorry about that, people. All right, so this is just straight multiplying. Well, there's two other ways of multiplying, and those are distributing and foiling. And we're going to talk about those in our next upcoming examples. Okay, so here's a distribution example. This is number 3, and this is distributing. And we'll do this. So 3 radical 6 times 2 radical 2 minus 4 radical 8. Okay, so just a reminder that first you're going to multiply, then simplify. Right? So when we multiply here, we're going to multiply 3 rad 6 times 2 rad 2. The outside numbers, the coefficients get multiplied. So 3 times 2 is 6. And then we're going to take our radicals and multiply them together. And 6 times 2 is 12. So that first 3 rad 6 times 2 rad 2 becomes 6 rad 12. Okay, I'm going to bring down the minus sign because I'm multiplying a positive 3 rad 6 times a negative 4 rad 8. Positive times a negative is a negative. Coefficients are 3 and 4 when I multiply these two together. So that's going to be a 12. Then I'm going to multiply my radicals together. Rad 6 times rad 8 is rad 48. And now we have an addition and subtraction problem like last week. So here we have to draw that little line in between and simplify these separately. So rad 4, rad 3, the 4 becomes a 2. 6 times 2 radical 3 is 12 radical 3. Bring down the minus sign. Rad 48. The more you know your multiplication tables, the easier you can make these for yourself. 48 is 16 times 3. The root of 16 is 4. So I have 12 times 4 radical 3, which is 48 radical 3. And now these happen to have the same radicands, so you can just add and subtract your coefficients, and 12 minus 48 is a negative 36 radical 3. Okay? Now, sometimes if these radicands weren't the same, let's say you had 12 radical 3 minus 48 radical 6. If these radicands are not the same, this would be your answer right here. You would have multiple terms in your answer. And that's going to happen a lot with these. Don't think you're wrong just because they look strange. However, this one did have like radicands. So our answer was this negative 36 radical 3. All right, next example is foiling. And we're going to do one that looks like rad 7 plus rad 5 times 3 rad 7 minus 4 radical 5. Okay, now keep in mind, if you multiply a rad 7 times a rad 7, you get a rad 49, which is just plain 7, right? So I'm going to do this longhand for this one, but I may not continue to do that. And what I mean here is when I multiply this first term, rad 7 times 3 rad 7, I would just say it's 3 times 7. But I'm going to actually do the multiplication here for you guys that need this shown. So this is going to be a 3 radical 49. And then I'm going to multiply the rad 7 by the negative 4 rad 5. So that's going to be negative 4 radical 35. Remember, there's an invisible 1 in front of that rad 7. So you're multiplying the 1 times the negative 4. Now I'm going to do rad 5 times 3 rad 7, which is 3 rad 35. And then rad 5 times negative 4 rad 5, which is negative 4 rad 25. Okay, so now we simplify. Rad 49 is just 7, so this term becomes 21. These two terms can get added together. Excuse me. So negative 4 plus 3 is negative 1 radical 35. Radical 25 is just plain 5, so this is minus 20. All right, so like terms, 21 minus 20 is just 1. And on this term, just like you wouldn't write 1x, you just write x, you're not going to write 1 rad 35 either. You're just going to write rad 35. Okay, so we don't want to see those coefficients of 1 when they're multiplied. So this is just going to be minus, oops, that should be a 30. That should be a 3. Undo. Minus rad 35. Now this one is necessary because it's the subtraction of 21 minus 20. So that is your answer, is 1 minus rad 35. Okay. These also, answers when you FOIL can vary from, I guess technically 1 term, but usually it's 2 to 4 terms, depending on what you're multiplying. Okay, there's also a number of these in here with variables. Maybe I'm doing one of those next. I am going to do one of those next. So don't panic when you see variables in here. Just treat it the same way and go through and use the math skills that you have. Okay, so example number 5. We're going to have 6 altogether. Looks like rad x plus 1 quantity squared. Should I point out the boo-boo? No, I'm not. All right. Remember that when you have an exponent, that means that there's that many, there's 2 of these. So you guys should rewrite this as rad x plus 1 times rad x plus 1. This is going to come into play in the next problem as well, and we'll teach you how to deal with that. Now I'm going to FOIL. Rad x times rad x. You can either put, so rad x times rad x is rad x squared, or you can write it like this, or if you know that that's going to simplify to just plain x, just put that. That's what I'm going to do. I'm going to just write that because these are true, but they simplify to that, right? So if you can do all this in one step, rad x times rad x is just plain x. Rad x times 1 is rad x. 1 times rad x is another rad x. And 1 times 1, please don't make that 2, is 1. Now the only thing that will combine here are these. And remember, there's invisible 1s in front of here. So this x will come down. The 2 in the green box simplify to 2 radical x. And this 1 will come down. And you have no other like terms in this. So that will be your answer. And it doesn't matter what order these are in. Technically, your radical term should come at the end, but it really doesn't matter. So you could go 2 rad x plus 1 plus x, 1 plus x plus 2 rad x, whatever you want. The order does not matter. Okay? Now, last example, just so you don't panic and you know how to deal with it, is you are going to have a couple problems. So this is example number 6, where you're going to see a binomial cubed. Well, just like the last problem, this tells you how many there are of this. So this is rad 2 plus 3 times rad 2 plus 3 times rad 2 plus 3. Now, what I want you to do is FOIL those first two. So you're going to FOIL the first two. and ignore the third until you're done. Okay, I'm going to ignore that third by literally covering it up. So we're going to take this guy, cover him up for a minute. Bear with me here while I do this. So we're going to fill it. There. So we're going to just completely ignore that for the time being. And we're going to go through and FOIL. Okay, so when we FOIL here, rad 2 times rad 2 is just plain 2. If you need to write out rad 4 goes to 2, feel free, but I'm not going to. Rad 2 times 3 is 3 rad 2. Another 3 times rad 2 is another 3 rad 2. And 3 times 3 is 9. Then you have some like terms here. The 2 and the 9 become an 11. And the 3 rad 2 and 3 rad 2 become 6 rad 2. Now, when you get an answer that has multiple terms, make sure you're putting parentheses around the multiple terms. It's simplified as far as it can go. And so now you're going to take this one that you ignored. Oh, I wanted you to actually move. It's not moving. It's like copying it and pasting it 19 times. Why is it doing that? There we go. Okay, so now we need to take this guy, the 2 rad 3 that we didn't use, and it needs to come down here. Rad 2 plus 3. And now we're going to FOIL again. Okay, so now I have 11 times rad 2 is 11 rad 2. 11 times 3 is 33. 6 rad 2 times 6 rad 2 is going to be, and I'll do this for those of you that need it, 6 rad 4. Excuse me. I'd like to write just 6 times 2, but I don't want to lose those of you that might not know what's happening. And then 6 rad 2 times 3 is 18 rad 2. Now simplify anything you can. The only thing we can do here is, this is a 6 times 2, so this is 11 rad 2 plus 33 plus 12 plus 18 rad 2. And now I can combine like terms. 33 and 12 give me a 45. And 11 rad 2 and 18 rad 2 give us a 29 radical 2. Those are your answers. That's your answer. Once you have two terms that are not like terms, you can't go any further. Okay? So that's all of the examples. And you guys will have notes. These, technically, everything is due on Friday, May 8th. However, as per the last couple weeks, if I get your notes by Tuesday, at 11:59 p.m., you'll get 30 out of 25. Okay. And then you have 2 varsity assignments this week. And they are 6.4 and 6.4b. They both have 16 questions. They're the same types of questions. It's just so that you have plenty of practice, because we utilize multiplication. I mean, there's addition inside your multiplication problems, but we utilize the multiplication and the division quite a bit in both Algebra 3 and Pre-Calc moving forward. So we want to make sure that these are both strong for you. Like the last couple weeks, there will be classroom assignments for both, where you're going to turn in your work and your grade. So work as an attachment, grade as a comment, private comment. For those of you that don't seem to understand, these aren't like classroom comments. I don't want everybody to see your grade, especially if it's not good. So private comment on the assignment that tells me what your grade is. Most of you are pretty good at that, but a couple of you aren't. All right, next week we're going to divide. Then we're going to deal with radicals of higher degrees, and then that's it for the year. So we're almost done. A couple more note lectures and we're finished. So goodbye for now. Toodaloo.